Section 7.4, Spelling Suggestions Using Top-Down Design. Our task is to write a program that takes a word that's potentially misspelled and offers possible corrections to that misspelling. That's a big task that we definitely don't want to try to jam into a single function. Many programs, whether they analyze data, provide spelling suggestions, or guess the author of an unknown text, have three distinct tasks to perform. First, there's the input task. We need to acquire the data on which our program will run. Second, there's the process task, where the program does whatever it's supposed to do with that data. Now, processing the data is all well and good, but it's useless if our users don't know what our program's discovered through that processing. That's where the third step, the output step, comes in, and it's where we communicate something to the user. Table 7.1 summarizes this process.
Table 7.1, a summary of the input, process data, and output tasks.
You can see this input process output model at work back in our data processing example from Chapter 2. We needed to read the data from the CSV file. That's the input step. Determine the number of passing yards for each quarterback. That's the process step. And then output the quarterbacks and their passing yards. That's the output step. We can think about our spelling suggestions problem in a similar way. What's amazing here is that the input process output model gives us exactly the three sub-problems that we'll want to solve in our top-down design. Here's what we mean. Also see the example in Table 7.1. For the input step, we need to ask the user for the word for which they want to obtain spelling suggestions. For the process step, we need to figure out all the possible suggestions for the user's word. For the output step, we need to tell the user about all the spelling suggestions that we found during the process step. Notice that we started with one large problem to solve, the overall spelling suggestions problem. And now we have three smaller problems to solve. Our main or top-level function will end up calling any functions that result from this problem decomposition. We'll name this main function spellcheck. It's often, but not always, the case that we need a separate function for each of the sub-problems we identify. Take a look at the input step again. We need to ask the user for a word. While we could split off a separate function for this subtask, that would be overkill. Why? This is because Python already has a built-in function for asking the user for input. The function is called input, and we saw it at work in Chapter 3, Section 3.3.7, when we were asking the user to enter passwords. Do we need to split off a separate function for the output step? No again. The output step is just outputting stuff to the user. We know that we can do that with Python's already existing print function. Again, it wouldn't be a mistake to split off a function for this, and you may have done so if you were doing this problem decomposition on your own. What you'd notice, though, is that the function would be very short, consisting of not much more than a call of print, and at that point you might think again about whether you want it as a separate function or not. The process step, by comparison, is going to involve a lot more work. There's quite a bit that goes into figuring out all the possible spelling suggestions. We have to support deleting a letter, inserting a letter, changing one letter to another, and so on, which is way too much to keep all in our main spellcheck function. We need a separate function for the process step. This is what we need to work on next.